Good afternoon, students. How are you today? I hope we are good. I am Auntie Jos, and I'm here to take you mathematics. And the topic we are going to be treating today is algebra. And under algebra, we are having polynomial and equations. Yes, polynomial and equations. I will start by defining what a polynomial is. By the way of definition, a polynomial, it is an algebraic expression consisting of one or more terms connecting by addition and subtraction operators. We are going to be talking about what is algebraic expression. When we say that polynomial is an algebraic expression. Algebraic expression is a combination of variable. It's a combination of variable, constant, and algebra algebraic operators. Yes, algebraic operators. What does this mean? When we talk about a variable is letter A to Z. A is a variable, B, X is a variable, Y is a variable. So it's letter A to Z. Let's pick X. This is a variable. And a constant is a number. We can have number 1, 2, 10, 100, 1000. That's a constant. So a constant, let's pick 2. And we have algebraic operator. Algebraic operator is addition, subtraction, multiplication, and division. These are algebraic operators. So when we say is an algebraic expression, this is the expression. It has x, 2, and algebraic operators. So consisting of one or more terms. When we talk about terms, I will soon define what a terms mean. Connecting by addition or subtraction operators. We've already defined what an algebraic expression is. Algebraic expression consists of a variable, constant, and algebraic operators. And terms, by definition, is an expression formed by the products of numbers and or variables. Product of numbers. Terms is a product of number. I've already told us what a number is. A number is number 1, 2, 3 to infinity. Then we have a variable. I've already told us what a variable is. A variable is x. So we have x squared, for example, and or a variable. It could be only a variable or a variable and numbers. So that is what terms mean. And these have been connected together by addition and subtraction operator. They are being connected. All these terms, they are being connected by addition or subtraction. For example, when we have a term, this is a term. 3x squared is a term. 4y is a term. In this term, we have a number and we have a variable. In this term, we have a number to be number 4 and we have a variable to be y. In this one, we have a number to be 3 and a variable to be x squared. So when we now add them together by addition operators, it becomes a polynomial. When we combine them together by addition operator or by subtraction operator, in this case, we have 4y minus 3x squared. We have two terms here. 4y is a term, 3x squared is a term. When we now connect the two terms together by subtraction operator or by addition operator, it becomes a polynomial. Yes. Now, we have different types of polynomial. We have monomial. Monomial is a polynomial that has one or single terms. It has one or single term. That is a monomial. And the example of that is 3x squared. It's just a term. The term consists of, is a product of number and variable. That's 3 multiplied by x squared. Now, we have another type of polynomial, which is binomial. Binomial is a polynomial that has a two-term. In this case, we have 3x squared plus y 4y. This is one term, this is the second term. Is being connected together by addition operator. So this is a binomial. It has two terms. We have trinomial, which has a three term. The three term, we have one term to be 3x squared, the second term to be 4y, and the third term to be 2z. So we have three terms. And fourth term polynomial, we have fifth term polynomial. Fourth term polynomial has four terms. It has 3x squared, the first term, the second term is 4y, the third term is 2z, and the fourth term is 5. Then we have five-term polynomial. It has five terms. 1, 2, 3, 4, 5. The first one is 3x squared, the second one is 4y, the third one is 2z, the fourth one is 2y squared, and the fifth one is 5. So we have 6, 7, 10 term polynomial depending on the number of terms that we have in the equation. That will determine what number of the term. So we have 6 terms and so on and so forth. Now I want to move to the degree of a term. I've already defined what a term is. It's an expression formed by the product of numbers and variables, or by the product of only numbers, or by the product of only variables, or the combination of the two. Now, the degree of term, the sum of the exponent on the variable in a term. The sum of the exponent on a variable in a term. What is an exponent? Exponent is the superscript number indicating the number of multiplication. Is the superscript. When we say x squared, yes, the 2 here is the exponent. It's only indicating how many times we are going to multiply x by itself. How many times? In this case, we are going to multiply x by itself 2 times. X times x. That is what this means. When we say 5 raised to power 4, it means that we are going to multiply y by itself 4 times. And 4 here is the exponent. Yes, 4 years, we are going to say y multiplied by y, multiplied by y, multiplied by y in 4 places. You are multiplying y by itself in 4 places. So 4 here is the exponent. So we say that the sum of the exponent on the variables in a term. So when we have a term, this is a term, 3x squared y is called monomial because it's just having one term. It's not connected by addition operator or subtraction operator. It's just one term. So in this term, we look at the variables. These are the variables. How many exponents is the variable x having? It's having 2, showing that we multiply x by itself 2 times. How many exponents does y has? It has 1. And we may decide not to show it. Once we do like this, it shows that this y is raised to power 1. And we are saying the sum of the exponent on the variables, not on the constant. 3 is a constant. So you only consider the number of the variable on the variable, the number of the sum of the exponent on the variable. Now I told you our variables is from letter A to Z. So the variable here is x and y. So you check the number of the sum of the exponent. So in this case, this is one term. And how many variables do we have here? We have two variables. Two variables, x and y. And how many constants do we have? We have 3. Because here we told you that once we are not putting exponent here, it shows we only have 1 here. So when you add 2 plus 1, it will give you 3. So we have 3 degrees of term in this case. In this example, we have 3 degrees of term. In this example, the second examples, we see that this is b raised to power 4, b raised to power 4, b raised to power 4. And how many exponents do we have here? We have 4, and here we have 1. We can as well remove this, but what it indicates is that it has 1 exponent. So when you add 4 plus 1, it's going to give you 5 degrees. We have 5 degrees here. We have 5 degrees here. And in the second example, b raised to power 1, d raised to power 3. And this b raised to power 1 plus 3 will give us 4 degrees. This gives us 4 degrees. And in the third term, we could see that we have b raised to power 6. b raised to power 6. So we have 6 degrees. So these are the degree of terms in this equation. Now, moving to degree of polynomial is equal to the degree of the highest degree in the term in the polynomial. Degree of polynomial is equal to the degree of the highest degree. So when you have an equation, to determine the degree of polynomial, you have to first get the highest degree in each term. You check the degree in each term and you pick the highest. So in this equation, the first term has 5 degrees, the second term has 4 degrees, and the third term has 6 degrees. So in this case, you could see that the highest degree here is 6 degrees. So when they ask you what's the degree of polynomial in this equation, you are going to pick the highest degree. So the highest degree is 6 degrees, which is the highest. God bless you. Thank you.